Right, in this video, we're going to start talking about the next big topic in calculus, which is called um, integration or the antiderivative. This is our suggested homework problems from 4.1. Understand that integration or the antiderivative is the inverse function of differentiation, which we've been talking about in chapters 2 and 3. Once we got finished talking about limits and continuity in chapter 1, we went straight into the definition of the derivative, and then we learned our differentiation rules, applications of derivatives in chapter 3, and now we're starting to talk about the concept of an antiderivative. So let's start off with our first problem here that will show that relationship. They have given us a problem here where they have found the antiderivative and they want us to prove that this work is correct by taking the derivative of both sides. So if I start off with this, C is a generic constant, by the way, is what capital C is. Make sure that when you do your problems in WebAssign that you use a capital C for your constant of integration. Capitalization is important to WebAssign. So the derivative with respect to this variable that you see here will eliminate this integration symbol and this differential here and leave you with the integrand. And so we want to take the derivative with respect to x of 2x to the negative third plus c. So let's see if negative 6 over x to the fourth is negative 3 times 2 is negative 6. Drop the exponent by 1. Derivative of a constant is 0. Negative 6 over x to the fourth is equal to negative 6 over x to the fourth. And we have verified that that integration is correct. We'll talk about our integration rules as we go along. So we'll mostly be using the power rule, basic power rule that says that when I have x to the n dx, that what I'm going to do is raise my exponent by 1 and divide by that new exponent, and then I'm going to add a constant of integration on the end. Again, remember that that's a capital C. So it doesn't matter what this variable is. If this is t and t, then this is t. You'll see that in this problem. So what I'm going to do is number 7, dy dt is equal to 9t squared. I'm going to split the differentials like we did in the last section of chapter 9, or of chapter 3, 3.9, and make this 9t squared. Going to integrate both sides, and this is y of t is equal to, that 9 just sits there as a constant multiplier, t, raise the exponent by 1, divide by the new exponent, add my constant of integration. 3 goes into 9 3 times. Y of t is equal to 3t to the third plus c. And we're supposed to verify our answer by finding y prime of t, which is this dy dt, is 3 times 3 is 9, t to the second plus 0. So there's my dy dt is equal to 9t squared if this is my general solution here. All right. Let's look at number 9. dy dx is equal to x to the 3 halves. So again, split our differentials and integrate both sides. Y of x is equal to x to the 3 halves plus 1 is 5 halves. Divide by that 5 halves. We don't like to divide by a fraction. We prefer to multiply by its reciprocal. So the reciprocal of 5 halves is 2/5 x to the 5 halves plus c. And let's verify that dy dx is 5/2 times 2/5. They're reciprocals. They multiply to give me 1. X to the 5/2 minus 1 is 3/2 plus 0. So that's correct. Let's look now at number 13. 13 starts off with the integral of 1 over x root x dx. So I'm going to rewrite this. 1½ is 3/2. So this is x to the negative 3/2 in the denominator, right? Coming up to the numerator, we change the sign of the exponent. So like that. Then we're going to integrate. This is our first box here. Rewrite as x to the negative 3/2 dx. Integrate, and that will be x to the negative 1/2 divided by negative 1/2. So plus c, x to the negative 1/2 over negative 1/2 plus c. And I'm going to multiply by negative 2 over negative 2 to make that a denominator of 1. So that's going to be a negative 2, x to the negative 1/2 plus c. And then I'm going to bring this exponent down and write it as a square root again. Negative 2 over the square root of x plus c. That would be my simplified answer here. All right. Let's go ahead now and look at number 15. If I have the integral of multiple pieces, say a polynomial like this, then I can break it apart into separate integrals using my sum difference rule. That's one of the things we're going to do here. So integral of x plus 7 dx will be the same as the integral of x dx plus the integral of 7 dx. Don't forget that the integral of k f of x dx, that the constant multiplier k can come across. We're not using c for a constant because c will be used for a constant of integration. So we're using the letter k for a constant when we're talking about constant multiples in integration. So let's go ahead and raise this exponent by 1 and divide by the new exponent. We're going to raise this exponent by 1. I don't see it, it's x to the 0, but when I raise it up by 1 power, it's x to the first, divided by 1, I don't need to do that, plus c. Let's verify this answer. It's the derivative with respect to x squared over 2 plus 7x plus c is 2x over 2 plus 7 plus 0 is x plus 7, which is what I started off with in my integrand. Let's go ahead and look at number 19. Number 19 says the integral of x to the 3/2 plus 2x plus 1 dx. So I'm going to integrate x to the 3/2 dx plus, and I'll bring the 2 out right now, x dx plus integral of dx. So this is going to be x to the 5/2 divided by 5/2 plus 2x to the second over 2 plus, and the integral of any variable is the variable. Integral of 1 dx is x, like this. So 2's will cancel, multiply by the reciprocal here. like that. And let's verify. Derivative with respect to x of 2/5 x to the 5/2 plus x squared plus x plus c is going to be 5/2 times 2/5 is 1, x to the 3/2 when I subtract 1 from the exponent, plus 2x plus 1 plus nothing. This right here is my original integrand, so this is correct. Moving on to number 21. 21 says the integral of the cube root of x squared dx is the same thing as the integral of x to the 2/3 dx. So when I integrate, I'm going to add 1 to the exponent, that's x to the 5/3, divided by 5/3 plus constant of integration c. So this is 3/5 x to the 5/3 plus c. And I could write that as 3/5 x cube root of x squared plus c, but I don't want to have to use a product rule to check my answer here. I'm going to leave it in this form to check. So derivative with respect to x of 3/5 x to the 5/3 plus c is 1x to the 2/3 plus nothing is the same thing as the cube root of x squared, which matches my integrand. Let's look at number 25. The integral of x plus 6 over the square root of x is integral of x plus 6 over x to the 1/2 power. So when I divide like bases, I subtract my exponents. 1 minus 1/2 is 1/2. 6 integral x to the negative 1/2. Add 1 to my exponent, divide by my new exponent, plus add 1 to my exponent, and divide by my new exponent. Add my constant of integration. Change my division of fractions to multiplication by the reciprocal. And simplify. And then I would like to get this back to the form that I started off with. So I'm going to multiply by x to the 1/2 over x to the 1/2 to get the square root down there and something without a square root in the numerator. So this is 2x squared plus 12x over the square root of x plus c. And they tell me to verify. Check the result by differentiation. So I'm going to use this form right here before I multiply top and bottom to verify. Let's verify here. Yeah, let's leave this alone. I have no need to do that, especially because of that fraction. Just going to create a problem for myself if I try and make a common denominator and everything. I'm going to force myself to have to use the quotient rule. So let's leave it just like this, and then derivative with respect to x of 2/3 x to the 3/2 plus 12x to the 1/2 plus c is x to the 1/2 plus 6x to the negative 1/2. And here's where I want to multiply by x to the 1/2 over x to the 1/2 to get it back in the original form. That's x plus 6 over x to the 1/2 plus c. Oh, nope, I differentiated that away, is x plus 6 over the square root of x. There we go. All right, time to start looking at some integrals of trig functions. So integral of sine is a negative cosine, because derivative of cosine is negative sine. So negative, negative sine is a positive sine. Integral of cosine is sine plus c. Integral of, let's see, secant squared x dx is tangent of x plus c. Integral of cosecant squared x dx is a negative cotangent of x plus c. Integral of secant x tangent x dx is secant x plus c. And the integral of cosecant x cotangent x dx is a negative cosecant x plus c. Make sure you've memorized all of those so you can use them. We're going to use the first couple right here in number 29 right now. So integral of 5 cosine of x plus 4 sine of x dx will be 5 integral of cosine of x dx plus 4 integral sine of x dx. And we're still verifying when we are done here. So this is 5 sine of x plus 4 times a negative cosine of x plus c is 5 sine of x minus 4 cosine of x plus c. And when I differentiate this, 5 sine of x minus 4 cosine of x plus c. Derivative of sine is cosine. Derivative of cosine is a negative sine. Derivative of constant is 0. 5 cosine x plus 4 sine of x was my integrand, so this is correct. Let's look now at number 33. Instructions still haven't changed. 33, the integral of quantity secant squared theta minus sine theta d theta. Notice that the variable has changed, but our techniques have not changed. Integral of secant squared theta d theta minus integral of sine theta d theta. Integral of secant squared, we just talked about, is tangent, minus integral of sine, we just talked about, was negative cosine, plus capital C. So that's going to be tangent theta plus cosine theta plus capital C. To verify that, we're differentiating with respect to theta. Tan theta plus cosine theta plus C. Derivative of tangent is secant squared. Derivative of cosine is negative sine. And there you have our original integrand. So this is correct. Let's look at number 37. And we're going to start finding particular solutions. So we'll be solving for the constant of integration C. F prime of x is equal to 6x. And we're given the initial condition that f of 0 is equal to 8. So f of x is going to be the integral of 6x dx. F of x is going to be 6 integral of x dx. F of x is 6 x to the second over 2 plus capital C. So f of x is 3x squared plus c. F of 0 is 3 times 0 squared plus c, and that needs to equal 8. So 0 plus c equals 8. C equals 8. We come back to this f of x right here for our final answer, and we substitute our specific c value in for this constant of integration, and there's our particular solution right there, 3x squared plus 8. So now at number 39. '39 says h prime of x is equal to 7x to the 6 plus 5. We're given the initial condition h of 1 is equal to negative 1. So h of x is equal to integral 7x to the 6 plus 5 dx. So we have 7x to the 7th over 7 plus 5x plus c is our h of x, and h of 1 is 1 to the 7th plus 5 times 1 plus c needs to be a negative 1. So 1 plus 5 plus c is negative 1. 6 plus c is negative 1. C is a negative 7. So that means that h of x is equal to x to the 7th plus 5x minus 7 for our particular solution. All right, let's look at our next problem, which is 43. And 43 starts off with the second derivative, so we're going to need to have more than one constant of integration. So don't label them all C, give them subscripts like C1 and C2 and so on. So this is x to the negative 3/2, f of 4 equals 2. Sorry, that's f prime of 4 equals 2, f of 0 is equal to 0. So going back to the first derivative from the second derivative, that's the integral of x to the negative 3/2 dx will be x to the negative 1/2 divided by negative 1/2 plus, and I'll call this C1. So f prime of x will be equal to a negative 2 x to the negative 1/2 plus C1. F prime of 4, let's make this a negative 2 over the square root of x plus C1. Prime of 4 is a negative 2 over the square root of 4 plus C1 is a negative 2 over 2 plus C1 is a negative 1 plus C1. And that needs to be equal to 2. So C1 needs to be equal to 3. So f prime of x is equal to negative 2x to the negative 1/2 plus 3. F of x will be equal to the integral of negative 2x to the negative 1/2 plus 3 dx. So f of x is a negative 2 integral x to the negative 1/2 dx plus 3 integral dx. This is negative 2x to the 1/2 over 1/2 plus 3x plus C2. And that is negative 4 square root of x plus 3x plus C2, and we were told f of 0 is 0. So f of 0 is -4 square root of 0 plus 3 times 0 plus C2 needs to be 0. 0 plus 0 plus C2 equals 0. C2 equals 0. So f of x is equal to -4 root x plus 3x. Let's look now at number 52. 52 asks us to use the graph of f prime to approximate the slope of the original function f at x equals 4. So if I look at x equals 4 right here and come down, that looks like we're at 4, -1. So it looks like f prime of 4 is about -1. Then we need to think about if f of 5 minus f of 4 is negative or positive. Is it greater than 0? So from 4 to 5 here, the slope is negative everywhere, so the function is decreasing on the interval from 4 to 5. So no, it's not possible for y2 minus y1 to be a positive number there, because f of x is decreasing on the interval of 4 to 5, meaning f prime of x is less than 0 on that entire interval. F of 5 minus f of 4 must be negative. Let's see. Approximate any values for where f has a maximum and explain, right? So if the slope was positive and then becomes negative, the point where it was 0 is a local maximum. So I'm looking at this point right here, and that looks like 3.5. So there appears to be a maximum of f of x at x equals approximately 3.5. And that happens because if I look at the first derivative test here at 3.5, it appears that to the left, f prime has a positive value, and to the right, it has a negative value, and 3.5 is the 0 of the function. F prime of 3.5 equals 0. So that would indicate that there's a local max here at x equals 3.5. Approximate any open intervals for which the graph is concave up or concave down. So concave up would be that the slope of f prime is positive. So that's going to be from -infinity to, that looks like 1, union, and then from 5 to infinity. And concave down would be this place where the slope appears to be negative from 1 to 5. And we would have points of inflection at x equals 1 and x equals 5. I have no idea what the y values would be that correspond to that, but the zeros of the, or I'm sorry, the turning points, the minimum and maximum points of the first derivative, the places where its slope is 0, would be the points of inflection of the zeros of the second derivative. So this point right here, where x is 1, and this point right here, where x is 5, where the slope is 0, those would be points of inflection. All right. Let's go ahead and look now at our next problem, number 53. '53 says that f double prime of x is equal to 2x, and we have a horizontal tangent line. F prime of 2 is equal to 0. F of 2 equals 0. So f prime of x is integral of 2x dx. F prime of x is equal to 2x squared over 2 plus c1. F prime of x is equal to x squared plus c1. F prime of 2 is equal to 2 squared plus c1 is equal to 0. 4 plus c1 equals 0. c1 equals -4. So f prime of x is equal to x squared minus 4. F of x is equal to integral of x squared dx minus 4 integral dx is x cubed over 3 minus 4x plus c2. And we have the point 2, 0 given to us. F of 2 is equal to 2 cubed over 3 minus 4 times 2 plus c2 needs to be 0. 8 thirds minus 8. 1, I'll multiply by 3 over 3 to make it a common denominator, is going to be 8 minus 24 over 3 plus c2 equals 0. c2 minus 16 over 3 equals 0. c2 equals 16 over 3. So f of x is equal to 1/3 x cubed minus 4x plus 16 thirds. Moving on to number 57. A ball is thrown vertically upward from a height of 6 feet with an initial velocity of 60 feet per second. How high will the ball go? In this problem, they want us to start off with our acceleration due to gravity in feet per second squared, but it's -32. So my velocity equation would be the antiderivative of -32 dt. Since everything is changing with respect to time, that's going to be -32 t plus c1. And we were given an initial velocity when time was 0. So that's -32 times 0 plus c1 will be 60 feet per second. c1 is 60 feet per second. So v of t is -32t plus 60. Position equation S of t is the integral of -32t plus 60 dt. That will be -32t squared over 2 plus 60t plus c2. So that's a -16t squared plus 60t plus c2 is our S of t. and our initial position is going to be equal to 6 feet off of the ground. That's going to be 0 plus 0 plus C2. So C2 is equal to 6 feet. And so our S of t is going to be negative 16t squared plus 60t plus 6. In general, and we'll use this later in the assignment, the S of t is equal to a negative 1/2 g. It depends on whether you're using a positive or negative number for g, but this should be a negative coefficient. So negative 1/2 gt squared plus v0t plus s0. So for instance, if we are dealing with meters per second and meters, this is negative 4.9 t squared plus v0t plus s0. And if we're dealing with the engineering system with feet and feet per second and so on, then this is negative 16t squared plus v0t plus s0. This is metric, and this is engineering system. All right, we haven't answered the question yet though. How high will the ball go? So the maximum height is going to happen when b equals 0. So come on up, back up here to v of t. Set it equal to 0, negative 32t is equal to a negative 60. T is equal to 60 over 32 is equal to 15 over 8. These are seconds. So S of 15 over 8 is going to be negative 16 times 15 over 8 squared plus 60 times 15 over 8 plus 6. I really don't feel like finding the fractional answer for the position because we probably want the decimal answer, so I'll stick this into my calculator at this point. 15 over 8 raised to the second plus 60 times 15 over 8 plus 6 gives us an answer of 62¼ feet above the ground. So now at number 59. Balloon is rising vertically with a velocity of 16 feet per second. The 0 is 16 feet per second. When it releases a sandbag at an instant where it was 64 feet above the ground. So the sandbag is 64 feet above the ground. It was traveling up with the balloon before it was released. So it also had an initial velocity of 16 feet per second, and its acceleration was negative 32 feet per second squared. How many seconds after it's released will the bag strike the ground? So we are given that A of t is equal to a negative 32 feet per second squared. B of t will be the integral of negative 32 dt. So B of t be negative 32t plus c1. B of 0 is c1 is 16. So B of t is negative 32t plus 16. S of t is the integral of negative 32t plus 16 dt. So S of t is negative 32t squared over 2 plus 16t plus c2. S of t is a negative 16t squared plus 16t plus c2. S of 0 is c2 is equal to 64. S of t is equal to a negative 16t squared plus 16t plus 64. First question, how many seconds release until the bag strikes the ground? So let's set this equal to 0 and y equals negative 16x squared plus 16x plus 64 and 6 second calc 0. Only interested in this positive answer over here because time needs to be a positive value. So t is approximately 2.5615528. And what's its velocity at that time? Then v of 2.5615528 is going to be equal to negative 32 times 2.5615528 plus 16. So my calculator's holding the whole value that it knows, even though I'm just writing those decimals. So I'm going to use the x that it just solved and say negative 32x plus 16, and it's going to give me the exact answer here for what this is, like I had used the entire square root, and it's going to be negative 65.96969,001, and these are feet per second, and these are seconds here. So book will approximate this to 562, and it will approximate this to negative 65.970, but it's using the exact value to calculate the velocity. So don't use the rounded value to calculate the velocity, or you won't get the right answer in that problem. All right, we've done enough of these position equations that they're just going to let us use what we know the equation to be, that we'll be able to say S of t is equal to, and then we are in meters, so negative 4.9 t squared plus b naught t plus s naught, and they tell us s naught is 2 meters. And we want to reach a maximum height of 200 meters, so that's going to happen when s prime is 0, so s prime of t, which is b of t, is equal to negative 9.8 t plus v naught. I need to set that equal to 0 since that's where my maximum height is going to occur. Negative 9.8 t is equal to negative v naught. Divide by negative 9.8, divide by negative 9.8. T is equal to V naught over 9.8. So come back to our position equation. S of V naught over 9.8 is negative 4.9 V naught over 9.8 squared plus V naught over times V naught over 9.8. Let's make a common denominator here by multiplying by 9.8 over 9.8 plus 2, common denominator 9.8 squared over 9.8 squared is equal to negative 4.9 V naught squared over 9.8 squared plus 9.8 V naught squared over 9.8 squared. I'll just leave this part alone. Plus 2 is equal to 200. So 4.9 V naught squared over 9.8 squared is equal to 198. 198 times 9.8 squared gives me 19015.92. 4.9 V naught squared. Divide this by 4.9, and I get V naught squared is 3880.8. Take the square root of that, and I get V naught is approximately 62.3, and this is in meters per second. All right, that's it for this video, and we'll come back next time and start talking about 4.2. See you for the next video.